All right, now last but certainly not least, we have Michael Haynie. Michael is a software engineer with a background in enterprise e-commerce solutions. He recently built a real-time online multiplayer game from scratch to learn more about TypeScript, WebSockets, and event sourcing. Currently lives in Phoenix and spends most of his free time playing volleyball and binging Wikipedia. Take it away, Michael.
Hey everybody, my name is Michael Haynie. Thanks for the introduction, Andrew. That was great. Today we're going to talk about Temporal and specifically the TypeScript SDK that they provide, and then do a short little demo just to show you what development with Temporal and TypeScript looks like. So not everyone knows about Temporal, but just a quick lightning introduction. Temporal, this is a definition I like. There's a lot of really wordy ones, but this one makes sense to me on a high level. So Temporal is a workflow engine for coordinating microservices through long-running and error-prone workflows. Some good examples of that would be something like your Netflix subscription for monthly billing. Another example would be background checks. This is actually a real-world use case for Temporal. They specifically had an issue with what they call person-in-the-loop workflows, which involves people making decisions, not just machines talking to each other. And Temporal was a good tool to solve that issue. And then the last example I have here would be something like ride sharing. And I added that because that's actually what the creators of Temporal were working on when they were creating it. And it's also the example that we're going to do today. We're going to do a simplified Uber workflow. So that's Temporal. Quickly, how does it work? There's absolutely no way in 10 minutes I'm going to be able to dive into how Temporal works. But what I want to do is cover two basic concepts that will help this demo make more sense. There's two main units of execution, I should say, that Temporal divides its code into. You can think of these at the code level both as functions, but they have certain constraints. Workflows are aptly named because they are they basically scope they span the whole workflow, but then activities are smaller and they go inside workflows. Workflows must be deterministic because Temporal is all about being fault tolerant and not losing any work. And so if the server crashes in the middle of a workflow, it's actually able to recover state all the way up to the last line of code that was run. And to be able to do this, the workflows and the code inside them must be deterministic. But of course, we have activities in our workflows, like calling third-party APIs or pulling a file off of a hard drive that are obviously not deterministic. So we wrap those in activities, and Temporal is able to encapsulate that there and keep this fault tolerance alive. So with that out of the way, let's do our live demo. It's going to be a simplified Uber workflow where the client can request a ride. A driver can accept it, which will transition you to the drivers on their way state. Or after 30 seconds, the system will automatically time out and it'll transition you to the no drivers found state. So I'm going to jump into code. And first thing I want to do is I just want to show you the client, which you can imagine this would be just like code that's running. Say you're requesting a ride and you've got the Uber app on your phone. This would be code that's like on the app that's going to interact with your Temporal server. So it's really simple. We're just going to create a connection using the Temporal SDK and then a programmatic client to communicate with the Temporal cluster. And then we're simply just going to start this workflow, pass it some arguments with an ID. And then once that workflow started, we're going to log out started workflow. And when it finishes, we're going to log out the result. And while we're doing that, I'm actually going to get that started just so we can see how it works. And there's just a simple NPM script we have set up to do that. Let me clear this first. So we have started workflow. Oops. We have started workflow going on there. And we can also check this in the temporal UI. So we can actually go in here, if we refresh the page, and see our workflow that we just started. It's currently running. And if we click into it, we'll get some more meta data on it. And if we want even more granular information about it, we can actually go into the history and see all the steps that it's taking to complete this workflow. But we haven't actually covered the workflow yet, so let's take a look at that. So this is the workflow. In an oversimplified manner, I said it's just a function. That's what we're going to look at it as today. The first thing it does is it executes this request to ride function, which is actually an activity. But for the purpose of demonstrations, it's just kind of like a fake one that we're console logging from. But this is where you would do non-deterministic functions like hitting a third-party API. Once that's finished, we're going to, we're going to set up some state to track whether or not a driver has accepted the ride. I'm sorry, IntelliSense keeps getting in the way. And then what we're going to do is we're going to set up a handler so that we can, we're going to set up a handler for a signal. And a signal is just a way for outside processes to get information into a currently running workflow. In this case, it would be a driver accepting the request and letting the system know that we can go ahead and move forward. And then this if condition here uses this condition helper from the SDK. It's a fancy way basically to say if this predicate returns true, go ahead and return drivers on the way. Otherwise, if this timeout happens first, which is going to be 30 seconds, we're going to return the no drivers found. So that is what happened this first time around. We got the no drivers found, and we can also see that in the web UI. If we refresh the page. Right, no drivers found. All right, so let's quickly take a look at the other use case. To do this, I'm actually going to use another script, which is going to send that signal indicating that a driver has accepted the ride. And this looks almost exactly the same as the client that started the workflow. We're going to create a connection and then a client. And then we're going to use the SDK to get a handle of that workflow using the workflow ID. And then we're simply going to signal into it using our established signal. It's going to console log that the signal has been sent and then terminate. So let's get that set up in this third console. But it's going to be a different workflow ID though. Start up a new workflow. All right, so workflow ID 823. And then, all right, signal has been sent. If we take a look at the output from our client, it says driver is on their way. And we can go check that in the temporal UI as well. We got our workflow 823. We can see drivers on their way as the result. All right, so that is a quick demo of two different use cases. Just real quick, I want to do one more, which would be demonstrating a little bit of the fault tolerance of the temporal system. And so I'm going to start a workflow. All right, workflow 146. We can see that that is running here. And then what I'm going to do is I'm going to just kill the worker. So the worker is a separate process that is essentially executing activities and workflows as needed. And the temporal server itself is more just coordinating that. But with my local development environment, there's only one worker here, where in production there'd probably be an army of them. But since there's no workers to process this, it's not going to be able to move forward. But even though we stopped it right in the middle of the workflow, once I spin this back up with npm start watch, It's going to pick right back up where it was, and it returns the no drivers found because the timeout has already happened. If we refresh the UI, we can see the same results there. So this is a very simple example of what Temporal can do. It can do a lot more, but obviously we're constrained for time. So that is all I've got for this demo, and it's actually all I've got for the presentation at large. So if there are any questions, I'd be happy to answer them.
Did we burn out all our questions? Oh no, we got one. What kind of project would need such a tool?
A good example would be a project that we're using it on for one of our clients right now, which is an e-commerce project where we have tons of orders coming in and they need to process payment, check for taxes, all sorts of stuff that it's coordinating microservices, right? And it's really vital code because you can't drop anything, but it's also very complex and very error prone. It needs to be running all the time. So that's a prime example of something where you have a complicated workflow coordinating lots of different microservices that you need to be able to dig into and investigate and figure out what went wrong if something goes wrong, or just keep tabs on with something like the Temporal UI. That's a good question. Thanks.
Great. Does Temporal come with any security features for handling transactions?
I assume you mean like money transactions and not like database transactions. I actually don't know. That is a good question. There's a huge the Temporal documentation is really great. There's a huge file dedicated just to security and stuff, but it was more like a production deployment checklist, and so I wasn't taking a look at that as I was learning this. But I'm sure it wouldn't be that difficult to find the answer to that. They have fantastic docs. It's been a pleasure reading through them.
Okay. Can I just use any library, or are there libraries for Temporal specifically, like a plugin ecosystem?
Absolutely. So there, we're just looking at the TypeScript SDK. I know there's another Go SDK, and then I believe there's another one oh no, there's definitely a Java SDK, and I think there's one other one. The TypeScript SDK is technically in beta right now. Oh, it might be PHP, yeah. And so typically the temporal cluster, which is managing the state and coordinating the service workers, that's just like a Docker image that you deploy. But your SDK that you embed into your services to start workflows or signal into them, or basically integrate with the real world, as you call it, the real world, you have those different SDKs to do that.